Hello grade 8s. So far we've talked about how to describe linear relationships. These are these patterns that when graphed form lines. We've created some expressions based on them. And this morning, what we'd like to do, or this afternoon, or whenever you're watching this, we want to go from an equation, which is that, I guess, that expression, but now has an equal sign in it, and we want to make a graph based on this linear equation, let's say. And so that's our goal today, is getting that done. So in order to do this, there are 3 steps that you will need to do. Number 1, you're going to have to make a table of values. And a table of values is always kind of our in-between step. If we're going from a graph to making an equation, or in today's case, if we have an equation and we're going to make a graph, our in-between step is always making a table of values. It helps us come up with these ordered pairs that we can use in our graphs. So the first thing we want to do, make that table of values. Second, we're going to graph the ordered pairs, and we also want to keep in mind that we want to choose variables that are meaningful. If I'm talking about time and distance, I might want to use the letters T and D to represent those different quantities. And so, yeah, that's what I mean by choosing variables that are meaningful. So let's look at an example and get this started. So you should have these in your notes as well. I know it might be kind of hard to see on the board, but hopefully you have this in your notes. And I'll also read it out. Paula rents a lawnmower for $8 per hour. A formula representing this relationship is C equals 8T. So this is important. This is our formula. The cost is $8 times the amount of time, $8 per hour. So our first step, I guess I should read the rest of the question, where C is the rental cost in dollars and T is the time in hours. And so Paula's renting this lawnmower. And so what we're going to do is we're going to make this table of values with time and cost. I know it's kind of backwards, but typically the variable that I see on the right, I put it in the left-hand column, and I put cost here. For some strange reason in math, our x values are typically on the right, and so that's just something to keep in mind. And then I'm going to make my table of values. I could use like 0.75 of an hour or 3/4 of an hour, but I want to pick some values that are easy for me to mentally calculate and put these on my graph. So typically, whenever I'm making a graph, when I'm choosing I know there's a T here, but my left hand is my X column. So I'm going to say whenever I'm choosing my X values, I usually just use 0, 1, 2, 3, because these are values that are easy for me to calculate. Where did I get these numbers from? I actually just pulled these numbers out of my head, because it really doesn't matter what numbers you put here. For any number that you put here, there's going to be an associated cost. At least for my positive numbers anyway. And a negative too, I guess, but in this example, the positive ones are going to work the best. So in summary, it doesn't really matter what numbers you put here, there's always going to be another value that goes here. So put any number you want here. I just chose these because these are the easiest ones to do. So if I rent the lawnmower for 0 hours, I pay 0. If I rent it for 1 hour, I pay $8. Rent it for 2 hours, 16, and 3 is going to be 24. And so once I have this table of values, I'm now in a position where I can make a graph. So part B, graph the ordered pairs in your table of values. So I have time on my x-axis, time in hours, and I have cost here in doll hairs. And so here are, I'm gonna start labeling this. 1, 2, 3, 4, 5, and so on. I might just go by 5s on this. 10, 20, 30, and so each increment is 5, but I just labeled every second one. And then I'm gonna start plotting these points. I got a 0, 0. I have a 1, 8. I have a 2, 16, and a 3, 24. And then I can draw a line through this and my graph is done. Almost drew a line through it. And so when you get to your textbook questions, you can definitely do something like this on graph paper. That would be great. However, when we get to assignment 9.3, I'm going to need you to do all of your graphs on Google Docs and Google Sheets. So that is kind of what we're going for there. Okay, one more example, and you'll see some of these as well. In this case, we have the equation y equals 2x plus 3. And we're going to use this equation to answer the following. Make a table of values, use integers only. So I'm going to start by making the table of values, draw a t, x, and y. And I got my table of values there. So again, this is the hardest part of the whole lesson, is what values of x do I use? The answer is it's your choice. You get to pick what values of x you're going to use. Like I said, for me personally, I prefer using 0, 1, 2, 3. I do that every single time, unless I kind of get the sense that there's this 4-quadrant graph, then I might pick some negative integers as well. But for now, the easiest ones in my brain to do are 0, 1, 2, 3. So that's what I'm going to do. I'm going to keep it easy, keep it simple, and try not to get too complicated. So for every value of x here, there's also going to be some value of y. So I need to figure out what this y value is going to be, and I'm using this equation to figure out my y value. So here's my original equation, y equals 2x plus 3. And so I want to figure out what x is, or what y is, when x is 0. So in this, what is y when x is 0? Well, I'm just going to replace this x here with 0. And then figure it out. What's 2 times 0? 0. What's 0 plus 3? 3. That's why I love x being 0 the best, because it's super easy to multiply things by 0. It's just 0. And so I used this equation to figure out what my y value is by substituting this x value wherever I saw an x. Let's try a couple more. What is y when x is 1? So now wherever I see an x, I'm just going to put the number 1 and then carry out this expression. 2 times 1 is 2, plus 3 is 5. So when x is 1, y equals 5. That's why I love having an x value of 1 as well. It's also super easy to multiply things by 1. It's just whatever that first number was. Okay, next one we have, what is y when x is 2? Now things are getting a little bit trickier. Now I got to multiply something by 2. Terrible news. But I think it's still doable. So wherever I see an x, I'm going to put a 2 and then figure out what y is. 2 times 2, 4. plus 3 is 7. So when x was 2, y is 7. And now I can kind of see that these are just going up by 2's. So now I'm going to throw these puppies on a graph. There's x and y. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6. Should just label every second one. Oh well. Okay, so this special point here, the origin is 0, 0. So when x is 0, y is 3. When x is 1, y is 5. When x is 2, y is 7. When x is 3, y is 9. Grab the meter stick and throw a line through those, and I'm all done. So in summary, what are we doing today? We're going to look at the equation. Then we're going to draw a T and make that table of values right there. That's our in-between step. We're going to fill in that table of values, plot the points, and Bob's your uncle. That's it. Take care, guys. All the best.